All right, good afternoon, everyone. Thanks for coming in. I hope you had a good lunch, or actually, I hope you had lunch before you came here. So I don't know if it's a good thing or a bad thing that the sessions after lunch. I try to get an early lunch and I'm a little sleepy, so I hope I have three challenges here. Number one, to keep you awake. Number two, to talk as much about memory tiering so you understand not only how it works, but also how to deploy it, how to kick the tires. And number three, not to lose my voice. This is my 7th session this week, so I've been talking a lot, but I enjoy it actually. So I talk to a lot of customers, a lot of sessions. Great time. My name is Dave Morera. I'm in technical marketing for core vSphere, but I do a lot of different things. Take care of whatever's the underlying hardware, GPUs, all the PUs, GPUs, DPUs, CPUs, accelerators, all that stuff. But also when it comes to memory, I deal with that. Memory tiering obviously is one of my things that I take care of, and core vSphere, as well as Private AI Foundation and Private AI services. Yeah, just a few things. So with that, I'm going to get started. There's a lot of content here. I call it a deep dive for many reasons. Number one, I'm a scuba diver instructor during the weekends. So obviously I had to put something about diving. But also I do want to get deep onto how it works and some of the advanced configurations for memory tiering. Now, you've seen this disclaimer a few times this week, hopefully. So you've been attending to sessions. All this that I'm going to talk about is already public. We have a few blog posts out there, white papers on performance, actually, which is pretty good. So I encourage you to go out and do some Google searching there for those topics. So again, I'm going to talk about the overall memory tiering solution, what it is, how it works, redundancy, which obviously is something that comes up quite often, security, how to deploy it, advanced configuration, and then a little bit behind the curtain, what does it look like from the VM kernel standpoint. So I want to start with the problem statement, right? When we start developing software, it's not just, let's start doing something and see if it sticks. We always look at the problem. What is it that our customers are telling us that they have a problem with? And one of them is memory. If we look at memory over the years, they have not scaled as much as CPU cores have. So CPU cores are doubling, tripling every year, every 6 months, right? It's going crazy, but memory kind of stays flat. Not until DDR, it came out not too long ago, that we've seen some increase in density, but not much. And even those dense DIMMs are really, really expensive. So if you are creating a bill of materials for new servers, you will find out that most of the cost, about 80%, comes from memory, right? It's a lot of money. And we also know that a lot of those pages, the memory pages, are really not doing anything. So you're buying really expensive RAM to just sit there. It's like buying a Ferrari to commute to work and sit in traffic. Doesn't make sense, right? So what we're seeing is something like this. We're seeing hosts that maybe have enough CPUs, but they're memory bound. And CPUs have to talk to memory constantly. And memory has to talk and retrieve, give information back to the CPU. So there is a back and forth there. So it is very inefficient because now you have all these resources from a CPU standpoint that you can't really use because you're out of memory. So those CPUs really can't do anymore, and you're wasting not only those resources, but also cooling, power, rack space, all that stuff. You could have been doing a lot more. The other problem is being able to scale your memory. So there's different techniques, actually. I've done this in my past life when I was an admin, a manager. What do, right? I need to lower my costs initially to buy servers because I have so much budget for CapEx. But I don't want to put myself in a situation where I'm out of memory and then I have to buy new servers later on. So I would do something like this, just buy one core, one CPU, fill it up, which worked great, right? It was lower cost, I was able to get some memory, and it kind of eliminates the NUMA performance hit if I had to go across to the other CPU memory. So it worked for a while until one time I didn't really pay attention, and the CPU I purchased was already on its way out. I could not find that CPU anymore. I couldn't fill that second CPU slot. Got into a situation where I had to buy more servers long time ago. So, that is something you can do. But even if you find a CPU, it gets full, then you run into the same scalability problems. Now, so what we're doing here is trying to solve that problem with NVMe devices. You already purchased your DRAM, but we know there's a lot of stuff, a lot of memory pages not being active. So by leveraging NVMe devices, we want to move those to NVMe when they're actually not doing a whole lot, right? And what this is doing is giving you that cost efficiency back. So reducing the load on DRAM by moving pages to NVMe, better CPU utilization because now we freed up some of that memory bound host, returning DRAM resources back, and now the CPU can actually do a little bit more work. We're constantly doing analysis on what is happening to those memory pages. And this came back from some of the work we did with PMM. Unfortunately, we couldn't do a whole lot with PMM and Optane going out, but we're always looking at the activity of those pages. Are you hot? Are you cold? What is happening? So that is something that we kept and we enhanced. So overall, this technology is giving you a lot of that reduce of the cost, more CPU utilization, and returning some of the expensive DRAM resources back to you. So if you look back into what we've done over the years with memory, right? We start with memory sharing. It's pretty much the first step that we do now. This is a TPS, transparent page sharing. So we're looking at duplicate pages, and we are just deduplicating them pretty much. So those, for example, guest OSs are the same, right? We don't need to have 15 copies of that. Memory compression, hardware-assisted memory virtualization, and then we move on until the techniques to alleviate that memory pressure that we're seeing. But once you get to ballooning and swapping, you start getting into some performance issues, right? We're trying to inflate artificially and trying to get some memory back to the host from the guest OS. Worst case, we're doing that at the host level with swapping. And you can definitely tell them that it's happening. At least I did. So memory tiering comes in not to eliminate this, but it comes before any of that. So we're kind of kicking everything down the road and say, okay, we understand the problem. We have some ways to get around that, but on top of the cost, we need to find a way to kind of not get to that level where we have to be swapping pages. So this is where memory tiering comes in. It comes before all of that I talked about. All right, so just like I said before, we're taking NVMe, pairing that up with DRAM. So logically, it looks like one logical unit of memory. To a VM or to a container even, it is 100% transparent. They have no idea that you've done this on the back end. The host, it does know, but we treat it as one. So we're gonna leverage that cheaper device, and we're gonna address that imbalance already between CPU and DRAM and lower the TCO in your environment. So how does that work? So here I have kind of like a similar representation of the first graphic, right? We have a memory-bound host. CPU is doing great, 50%, but we already crossed a threshold on the memory side. Maybe it's 75%, 80%, and 90% in this case. We really can't do a whole lot, right? We're pushing the limits on memory. So this is where memory tiering would come in. We add that layer of hardware, present it as one logical unit, and move some of those cold pages down. Now, in this case, this is an over-exaggerated animation because we're not moving pages just because. So some of those cold pages may stay up there. We may get a lot more hot pages coming in, but we're trying to use as much of DRAM possible as we can. And when we have pressures, then we're moving those pages down to NVMe, right? So it makes sense. We don't want to just do it and get a performance hit just because. But in this case, now we have all that additional space for DRAM. We still can move some of those cold pages down to NVMe, and now the CPU can be pushed even more. So now we're using more CPU resources. We're using more of the DRAM for actual work. And we're using NVMe for the cold pages and very cold pages that don't do a whole lot. So I hope that makes sense. So this is pretty much how memory tiering is from a high-level view. So one of the questions I get is, what about redundancy? And does it work with everything else that we have? We have a ton of features within vSphere by itself, let alone VCF. How does it work? Is it really compatible with everything? Well, let's see. So for redundancy purposes, we do support RAID, hardware RAID. And so we're looking at one device per host dedicated to NVMe tiering, or one logical device per host. So you can have RAID 1. We really don't tie you down to RAID 1 or RAID 10. So if you want to add more devices and make a bigger logical device, go for it. But RAID 1 would be good enough. So we do support that redundancy from that standpoint. So hardware RAID is supported, tri-mode is supported, and VROC is supported as well. I don't know if I consider VROC hardware, but we support it in that space. Now, interoperability with all the other features. So HA is aware, and I'll show you at the end how this works on the back end. HA is aware, DRS is fully aware on this version 9. Fast suspend resume, it is supported. There are some changes there with the encryption portion of this. I will talk about that in a second. RAID is supported, and then vMotion obviously is supported. And one of the questions I usually get at this point is, well, how does vMotion work, right? How does the one host knows if the other host doesn't know? So what happens during the vMotion process? So here we have VMs doing their thing, memories coming in, and again, hot pages would be vMotion over from DRAM in the source to DRAM on the destination side. But what if we have cold pages? So we don't really read directly from NVMe to copy those pages over. We actually copy them up to DRAM, to a cache location, and then we copy them over to DRAM on the destination. So from a destination standpoint, all the pages are coming in, they're looking as hot pages. They were read, and they're getting written into the destination host. So for now, we're not really keeping track of their activeness state as we're moving them. We do keep activeness state when they're locally, right? If they get cold or hot, and we move them accordingly. But when they're getting moved over, at least for the version 9, we don't keep track of that. Everything's coming into DRAM. So a caveat here is that vMotion may take a little longer depending on the amount of memory that you have. What if the destination host doesn't have memory tiering enabled, which we actually support? Well, the same process happens, right? Because we're not reading directly from NVMe, and everything's coming in directly to DRAM. So again, hot page will come in, copy that over to DRAM on the destination, and a cold page gets copied up to cache and gets copied over to DRAM on the destination. So pretty straightforward. So whether you have it enabled or not, it is the same process. Failure scenarios. This is also a common question. What happens when my single device fails, or what happens when if I have RAID and one device fails? So with RAID, pretty straightforward. You're already mirroring that data. So we just pretty much fail over to the other NVMe device. So that gives you that redundancy that you want. And with a single device, you actually triggering a VM task here. Now this HA event is for the VMs only, because we don't store any VM kernel pages on NVMe, right? So the VMs do fail, and they get HA over to a different host, again, for the VM pages only. Yep, there we go. All right, another question I get is security. Is it secure, right? Is it, do I use VM encryption? How does this compare to vSAN encryption? Do I need a KMS? How does it work? Well, we actually came up with a different way to encrypt it. So now we have vSphere VM encryption, which is not what we're using here, but we're using two approaches. So one of them is host level NVMe encryption, and this is pretty much a configuration setting for both at the host level or a VM level. So we're telling it where to configure it. Here's pretty much how they work. So a VM encryption, which is different from the regular VM encryption. So a VM level encryption for NVMe tiering, it's per VM, right? We go on VM per VM and you're saying, okay, I want you to be encrypted when it comes to memory, or not, or we can just go to the host and every VM in that host would get this configuration. Now from them on, it's pretty much the same. The host is going to generate the encryption key. We have a 256-bit encryption key. We use AES-XTX, and the key is generated in the case of VM encryption when the VM is powered on. As long as it lives on that host, that key remains. The only time we regenerate the key is when we do, for example, a vMotion to other VM. So we will decrypt the data, do the copy over, and then it will get a new key on the destination host. Now the pages as they're coming in and out of the NVMe device that you have configured for memory tiering only, that is, those are being encrypted and decrypted as they're coming in and out, as they're getting cold or hot, as they're being moved up and down. And the same for the host level encryption. So that is pretty much the same behavior between the two. All right, so that's pretty much an overview, and you like what you're hearing, you're interested, you like just let alone just the 40% decrease in TCO, but you want to learn how to deploy it. How do I do this, right? Do I need some crazy tool? Do I go through VCF? So no. So this is on vSphere itself. So whether you have VVF, VCF, this is available for you in vSphere 9. So some things to consider. Right? We are writing a lot of data, we're reading a lot of data, and we don't want to get into that place where, if you remember when we were putting from USB devices for ESXi, right? They fail because there's a lot of stuff going on. So we came up with some recommendations for the NVMe, the endurance class D and performance class F or G, right? So we're leveraging the vSAN compatibility guide, because in essence, memory tiering sort of looks like vSAN. We're almost doing the same thing, just with memory. But we have already built the database of all those drives that are compatible. And so this is an easy way together. So now we can go to the compatibility guide at Broadcom.com and make sure you check on those devices. Now, one thing I don't have here is the form factor. So we do support a variety of form factors. Could be 2.5 inches, M.2 devices, PCIe. I mean, you can choose a lot of them as long as they meet these criteria. So if you have a host and all your front devices are full, or your slots are full, I'm sure you have some PCIe slots open, or maybe M.2 slots open, you can pop one in, try it out, and go from there, right? So you have a lot of options to adopt this. Other considerations. So large pages are deactivated by default. So those are VMs with large pages of 1 gig or over. They're not activated by default. They're not encrypted, and we talked about encryption, right? So when you enable memory tiering, all those pages going into NVMe and coming out of NVMe are not going to be encrypted, but you have the option to do that at the host level or at the VM level. No other partitions on NVMe device. So here are two parts of information here. We don't want to share this device with anything else, right? You can buy an 8 terabyte device, that's fine, but don't think, oh, I'm only going to use half of it or a quarter. Maybe I just put some, use it for local storage or something like that. No, we don't want to use it with anything else because that's going to create a performance hit for the memory that is even more important for your workloads. Up to 4 terabytes, that's the maximum partition size right now. This is version 1 of memory tiering. I don't know if that's going to go up or not. So for now, the maximum partition size is 4 terabytes. Active memory, we want it to fit into DRAM. So this is a particular very important thing to look into, because obviously the active memory is what needs to be read and written really fast, and we want that to stay on DRAM. We don't want to have to move any of those pages to a slower NVMe device, even though it's high performance class. So when we're doing, and I'll talk about ratios in a second, when we're doing some sizing, we want to make sure to look at your workloads and make sure that fits into the amount of DRAM that you have. There are some VM profiles, and I have a list following after this. So obviously those VMs require low latency, high performance. Most of them already have memory reservations, so those are not a good candidate for memory tiering. Also, if your workloads have over 50% active pages, those are not a good candidate either, right? At least for now. Ratio comes into play. So DRAM to NVMe, those are things that changed from vSphere 8.0U3. And in 8.0U3, which was the tech preview, the beta version, we had a ratio of 4:1. So you can have 4 parts DRAM, 1 part NVMe, gives you 25% more of memory. So 1 terabyte host would get 256 gigs of memory, which is nice. But that's only 25%, so we want more. And with vSphere 9, now we increase that ratio to a 1:1. So that same 1 terabyte host can go up to another extra 1 terabyte equals 2 terabyte memory. And yeah, we're ready to discuss the endurance and performance class. Again, that is really, really important. I started working at VMware in a proof of concept team when vSAN was actually coming up. It was pretty new. And we saw tons of customers trying to get cheap on this area, right? They're like, oh, it's just storage, we don't care. So they would put in spinning Rust, really bad cache devices that were not certified for that. And of course, they were having tons of performance problems. So this is something that you should definitely look into it if you're considering deploying memory tiering. All right, so here are the VM profiles. So what fits into well, most workloads will fit into tier, we'll call tier VMs, is VMs that can leverage memory tiering. But there are some other ones that we don't recommend. So large pages, we talked about that. PCI pass-through VMs, those should only run on DRAM. The quick assist technology, VMs, and memory reservations. Usually those VMs that have vGPUs as well, they have 100% reservation, so they will fall into this as well. And some that are not supported, low latency VMs, we talked about the performance VMs, some security VMs, fault tolerant, and monster VMs. Yeah, definitely wouldn't put a monster VM in there with memory tiering. So again, this is version 1. These are the profiles that we have identified as, yes, they fit into memory tiering versus some that, yeah, maybe we shouldn't. But I know we're working on expanding this and getting rid of some of these limitations. How do we know what's a security VM? So, well, we look at the VMX options, VMX file. So low latency, there's a setting for that. Security, so we're talking about SEV, TDX VMs with that enable. Monster VMs, large pages, and nested VMs as well. Again, something that we're working on, but for now, those are some of the limitations. So those VMs wouldn't even power on if your hosts have memory tiering enabled. NVMe requirements, again, I said, so dedicated device, we want a device just for memory tiering, nothing else, right? No storage, no logs. We also want it to be locally, so nothing fiber attached or Ethernet attached, so local on your host, dedicated just for that, and not shared with any other workload. So no additional partitions for anything else. Again, so we kind of, yeah, we really don't want to share this for anything. We wouldn't want anything externally to affect the performance of the memory. So here are the ratios that I talked about, right? So again, initially it was a 4-to-1 ratio, and now the default, it's a 1-to-1. So you get 100% more memory, twice the memory. But there's some variables here. So the partition, when you go ahead and create it, is created dependent on the size of your drive. So if you have a drive that I would personally go at least 4 terabytes because that's the maximum partition size, right? Even if you use a smaller partition, with cell cycling, it will last you a little longer if you have a bigger drive. So definitely recommend that. So in my case, I would probably buy a 4 terabyte drive. And let's say my DRAM on my host is 256, right? So we create a partition, big partition, but we will only use 256 because our default ratio is a 1-to-1, right? So even though we have a larger partition, we will only use that. But one of the things that I mentioned before was that we're looking at active pages of those workloads, and we changed the default ratio. And this is also something that you can change later on. So the maximum supported ratio right now is a 1-to-4, which is the opposite of what we had. And so you can have 4 times as much memory as your host. That same 1 terabyte host can have now 4 terabytes from NVMe, plus what they had before. So, definitely quadruple your memory in a way. Again, the partition size may or may not fit. So in this case, well, I'm looking at the third row, the 1-to-4. So you see the DRAM size is 256. I have a 1-to-4 ratio, so I should be able to use 1 terabyte. But you can see here that the NVMe, the partition size is not big enough to give me that 1-to-4. Even though you configure that to be a 1-to-4, your drive wasn't big enough. That's why I recommend a bigger drive. And you could have had 4 times as much memory, but you only got twice as much, right? So those are things to look at. Again, when you're thinking about starting with memory tiering, think about the drive size, the performance, endurance, class, all that stuff. All right, so how do I know which workloads fit into that? Well, again, one of the things I talked about was 50% or less of active memory. Why 50%? Well, the default is 1-to-1, right? And we want all the active memory to fit into DRAM, so that kind of gives us the 50%. If you were thinking of using 1-to-4, then that should be obviously a lot lower, 25% or more, or less. Also, CPU utilization to be on the low side, and you get to pick your capable NVMe device. But what the most important thing here is to look at the active memory. So you can use different tools to look at your environment, use some of the vCenter performance UI that we have. I know we're coming up with more on VCF Ops to help you plan this. Essentially, like a what if I turn this on my environment, what happens? We will help you with that in the future. So I talked about some of the changes, and so here are some more. The mixed cluster, this means that some of the hosts could be enabled for memory tiering, some others could be disabled for memory tiering. Why? Because we already talked about those profiles that are not supported. Maybe you have a lot of those VMs, with large pages, high performance, low latency that you want to put them in one host, so you can enable some, disable others. Or you can actually disable per VM. You can go per VM and just disable memory tiering and just enable the entire cluster. RAID support, we talked about that. Hardware RAID support only for now. Wink, wink. The RS support, it's fully aware. We did a lot of performance improvements on the back end that allow us to go from a 4-to-1 ratio to a 1-to-1 ratio. All right, so how do I do this? So now, caveat here, I talked to the different teams, PM, UX. We do recognize we need to do a little bit better on the experience, but this is version 1, so give him a pass. So the first thing we want to do is check the NVMe devices. And I keep saying this because it's very important, right? What type of endurance and performance class does my host see this as an NVMe device? So, pretty easy step. Second one is to configure the partitions. So right now, this is done through ESXCLI. A couple lines, you create your partition. You don't even have to pass a size. You create the partition, and then you move on to the next step. The next step is configuring the host. Again, you can do one host, half of them, or the entire cluster. And right now, we do require a reboot for this to be enabled, to come on that feature, and then you can just verify if it's enabled or not. All right, so aside from ESX CLI, you can use Power CLI, so you can script this, make it easier, and then most of the rest is done through vCenter UI. So here's a quick, this is step number 1. Yes, we know we go into a host, we see the NVMe device, one logical device per host, so whether it's just one guy or RAID backed device, logical device there. So here's how you configure create the partition, right? So we used to ESXELI system tier device create, pass the device name, and that's it, right? No sizing, nothing. We used to go ahead and create it, and then that puts us into the next step. So the next step can be done through vCenter UI, or since we're here, we can just do it from the host. So another command, we just go into set memory tiering to enable. So here we set the value to true. And you can see here that it says configure true, but runtime is false. And this is why we need that reboot, right? Once we do the reboot, it's going to say true. Again, just one quick line for the partition creation, one line for the enabling of the feature. Or if you're lazy like me, you can leverage the UI. So you can go to the host, go to advanced settings, and just look for memory tiering and set that to true. Or even better, you can use desired state configuration and set that for the entire cluster, right? So you already created the partition. You just come here and look for that VM kernel option and set memory tiering to true. And just configure those hosts automatically, and it would actually do the reboot for you in a rolling base. Once it's done, then you can see an additional wording on the vCenter UI. So under advanced settings, it will say, okay, memory tiering, which was not there before, is set to software. And you will also see under configure overview, now it tells you how much you have the total memory, which was there already, but now you have a tier 0, tier 1. So tier 0 is going to be your DRAM, tier 1 is going to be your NVMe. And again, it's the same because we have that default ratio of 1:1. What else can you do? Well, we talked about other things like encryption. So host level encryption, super easy from the UI, advanced setting configuration, set the encrypt tier NVMe to 1, and that's it. From the VM level, same thing. Advanced settings, and just pass that parameter and set that to true as well. So that will set that specific VM to do encryption just at that level. Again, I would suggest probably do it at the host level. And you can also disable memory tiering per VM. So those VMs that fell under those profiles that were not supported, or maybe you're not sure, maybe the active memory is higher than 50%, then yeah, you do want to disable that, but you want the rest to be on, then you can go to that VM, edit the advanced configuration parameters, and set that to false. Now here's where you change the ratio. So this is done at the host level. So you see the tier NVMe percentage is set to 100. So when you configure, that's what you have, right? Because you get 100% more. That's a 1:1. You would set that to 400, you would get the 1:4 ratio here. So pretty straightforward to change. Just be careful not to change it unless you did your homework with the activeness of your host, of your workloads, I'm sorry. All right, so I'm getting towards the end here. So what's behind the curtain? So if you're gonna get real geeky about this, we can see the cluster level, what is happening behind. So DRS still does the placing, right? The VMs have no idea that memory tiering is enabled, so it's going to place the VMs based on the resources available. We're looking at the total VM as the addition of both NVMe and DRAM. So the DRS is going to look at the total memory available, and it's going to assign the host that way. Now, if we dig a little deeper into the host level, the host monitor is going to take care of the tier bandwidth of the host. It's going to kind of check, and it's going to do the memory sizing, memory tier sizing. And again, that depends on what values you have configured, and choose the sizing for the tier. If we drill down a little bit more into the VM level, now we're going to monitor the tier bandwidth of that specific VM and the placement of the pages, right? So here's where we look at the pages, and if they're active, they're hot, we're moving them up and down as needed based on that threshold that I talked about. So we try not to move pages just because we can. We're trying to move them when we have to. On an animation to kind of bring it all together. So again, memory VMs are doing their thing. They have no idea what is happening as far as memory goes. That's from the logical perspective. From the physical perspective, as a page comes in, it's hot, right? It's being read, it's being written. It lands on DRAM, stays there until it gets cold. And if it doesn't get cold, then it stays on DRAM. If it gets cold, then we move that down. If we have to, we move that down to tier 1, which is NVMe. So what happens if that page gets called up, right? Hey, I need to read that page, then it gets moved up to DRAM, sort of like we did with vSphere in the past. So it gets moved up to the fast tier, and then we read that from there, and we pass it to the host. And again, when pages get cold, we move them up and down as needed, and feed that back to the VMs. And we're constantly monitoring the activeness of the pages. So every between 5 and 15 seconds, I think that varies. So we're constantly looking at this. These are some things that we also started doing back with PMEM, but we have increased and adopted even more. And so we're actively looking at that. Again, we're moving pages when we have to NVMe, but we're moving them up when they're required to be read from DRAM. All right, so with that, I'll tie it up a little bit. Again, that gives us the lower TCO. You don't have to spend as much money based on your workloads, right? If your workloads are only using maybe 40% of active memory, right? Why not leverage this tool, right? Instead of buying expensive DRAM. So with lower TCO, up to 40%. So PMM, product management did a lot of calculations and talked to a lot of customers on what is actually happening in the environments. So by doing this, we can consolidate even more. Less servers means you can have more VMs per server, less servers in your environment, less power, less cooling, obviously less licensing as well. And then by freeing up some of those DRAM resources, you can also try to leverage some more of that CPU that's been just sitting there waiting for memory to free up, right? All right, so with that, thank you for coming. I think we have about 5 minutes left. If you have any questions, yes. Maybe. Yeah, question. There's a mic over here.
What's the process of deciding when a hot page gets cold? Is the ratio involved in that process, or is it a fixed process?
It's just the activeness. So when the page gets called, it's not being read or written, right? It's not being called up by the VM. And then after a while, if we cross a threshold, if there's a pressure of memory, we're going to push that down to NVMe, right? So we're looking at what is each page doing as far as activeness.
So it's not dependent on the ratio on NVMe and DRAM.
Correct, right.
Thank you.
Yep.
I was wondering if If I wanted to evaluate my options and how well tiering would help me, is there a way to find out how many of my pages are active versus cold without enabling tiering?
Yeah, so you can look at the vCenter UI and the performance. Look at that's probably the longest way. But you can also do like, what is that tool? RV tools to run a report in your workloads as well. It tells you kind of pretty much the active memory and things like that.
Okay, cool. Thank you.
I'm sorry. It sounds like there's a lot of homework that goes into this and prepping and knowing what the workloads are in advance. It doesn't seem very practical to me. Is there a way to just enable this capability and then dynamically turn it on and off when the system determines that it's beneficial?
So, I mean, you could if you want to enable it, right, and then roll the dice. But we are coming up with, like I said, a tool to help you plan, so you don't have to do any of this homework. So, and we're going to leverage VCF operations, so you can run actually a test, not really a test, but it's a simulation. And you can say, what if I want to enable memory tiering on this cluster, right? I don't want to have to go
Right.
and look at anything. And it tells you, yeah, it's a good candidate, yeah, or maybe not, or maybe yes, but not this VM, right? So we're coming up with tools to help you guys. Again, so we came up with the feature itself, and then we're gonna help you with the other part in
Okay.
next releases.
Thanks.
Yep.
A couple of questions related to large page size. So you mentioned that tiering, you need to disable the large page size. So several workload like Oracle utilize optimal on large page size. So do you expect Oracle shouldn't use tiered model in this case?
For now, for this version, no, right? Because you have large pages enabled.
Right.
But yeah, we're looking at that to expand that. So again, all those profiles that were not supported, we're looking into just getting rid of it in next versions. As
I
well.
see. The second question related to the same topic. So I built a VM without a tier. Over a period, I want to convert that into tier. What is the steps here in this case?
So if you enable the feature, they all get enabled. So if it's disabled, that means you went to the VM and disable it on the actual VM, right? If you want to enable it again, you just have to set that to false, and it will be back to the other pool of enable VMs.
Oh, I see. Okay. It's at the cluster level, this setting?
The host level.
Host level.
Yep.
I see. Okay.
Yep.
Okay, great. Thank you.
Hi. Is read actually recommended for the NVMe drives, or will you see some kind of performance hit?
What was the first one?
Is read actually recommended from your perspective for these drives, or will you see some kind of performance hit if you enable read?
RAID. Oh,
RAID.
there's going to be an overhead, yes.
Yeah.
Yeah, with hardware, there's going to be an overhead. But we're thinking about using software-based as well. But yeah, I mean, you can have to decide whether you want redundancy or just the performance of it.
Oh, okay. Thanks.
How long does it take for pages to go cold? I'm thinking like specifically like a DR environment where you bring the whole cluster up at once.
Well, I don't know how long it takes for them to get cold, but I know we look every few seconds, like under 15 seconds, to see the status of it, right? So we're not, like we're just tracking the activeness of each one of those pages. So if it takes a while, I don't know how long it would take really for them to consider it cold. But we're just looking, hey, when was the last time you got read? When was the last time you wrote into DRAM? Like, that's
Yeah,
what we do.
and just if you turn up every VM in the cluster at once.
Right, it could be a few minutes, like I don't know.
All right. And then say right now active less than 50% for candidate VMs. If you lower the ratio to say 50%, does that increase the amount of activity that you could use?
Yeah, you could push it more. Yeah, if you want to just instead of 1-to-1, you can do a 2-to-1, right? 50% more memory. Yeah, you could, if your workloads have more than 50%, but then lower than that ratio, whatever the math is, then yeah, as long as kind of the math aligns to that.
Cool. Thank you.
Hi, when is enabled by VM? So if the host does not have the NVMe, so it's supposed to be incompatible, but the VM is not moving there, or is gonna just move and don't use the resource.
If it's the if the VM is
If you enable by VM,
no, you enable by at the host level.
you cannot enable by VM.
No, you can disable the VM, but it's enabled at the host is the lowest or at the cluster level.
Why not enable by VM?
It's just a lot of work.
Yeah, but it's just I'm being.
But the NVMe device is attached to the host. That's the guy that knows what's happening. And then the VMs have no idea that tiering is happening.
Okay.
Right?
Thank you.
Yep.
Question about the CPU scheduling, host side CPU and virtual CPU. So swap space case, preemptive, but not this case. NVMe will take more time. Then during the time, host side CPU will start, or virtual CPU start, or preemptive to other thread.
If I understood your question, it's if the CPU takes a hit from this.
No,
right?
CPU is stuck, or getting other workloads, switch to other workload. Usually, in a load store, CPU will wait until data coming, but NVMe will take longer.
I see. Well, but the data would always come and leave from DRAM, right? So the move to NVMe is a post process. So from a VM perspective, it comes to DRAM, it's done, right? It forgets about it. And then what happens after that, then we do the move up and down of those pages, if that makes sense. So it's from the CPU perspective, once that's why we want DRAM to be the first step, because then it answers faster and the CPU.
So trying to read the data and the data doesn't exist at the DRAM, then what will happen? The CPU just stop and waiting until the data is loaded from NVMe to DRAM and start again?
Yeah, it's waiting for that to move up and then get right from DRAM.
So
there's a little bit of a hit if that's where you're going. There's like maybe 5% that we have a performance white paper we just published.
Okay.
So if you, I think it's on our blog, blogs.vmware.com, you want to look into that. There's a little bit of hit because of that when the pages come hot. Yeah.
Okay, I'll take a look at the blog. Thank you.
On the vGPU limitation, is that a hard limitation or just not recommended?
So the vGPU limitation is usually because of the memory reservation, right? If there's no reservation, then you should be good.
Okay. So if memory is reserved, it can't tier?
No, not for now. So, and that's kind of like a 2-point question, because you can have pass-through, you can have vGPUs, right? So pass-through is a no, reservation is a no for now.
Okay.
That's my question.
Yeah. All right, thank you guys for coming. Appreciate it.